To answer these three questions, we'll be utilizing the concept of applications of right triangle and trigonometric ratio. So first, let's label the important points in the figure. I have labeled the anchor 1 and anchor 2 as points A and B, and the top of the antenna is marked as C, and the base of the antenna is marked as O. So this OC represents the height of the antenna. OA is the distance of anchor 1 from the base of the antenna, and OB represents the distance of the anchor 2 from the base of the antenna. So we can now apply the concept of right triangles as well as trigonometric ratio to determine the distances of the anchors from from the base of the antenna as well as the distance between the anchor 1 and anchor 2. So to answer the part A question, consider the right triangle OAC. So here we first consider right triangle OAC. So in this right triangle, we know that the alpha is 0.31 radians. So I'm going to apply the trigonometric ratio tangent of alpha. So I write down tangent of alpha. This is equal to, remember that from SOHCAHTOA, we know that tangent of alpha is opposite side over adjacent side. So for angle alpha, the opposite side is OA is the opposite side. So I can write down this as OA over the adjacent side is OC. So I write like this. Now let's substitute the values which we know. We know the alpha is 0.31 radians. So I substitute alpha as 0.31. So this becomes a tangent of 0.31 equals, we don't know OA, so we write down this as it is, and OC is the height of the antenna, which is given as 165 feet. So we write down this as 165. So from this we can solve for OA. So when we multiply both sides by 165, we get OA equals 165 times tangent of 0.31. We now plug this into the calculator. Uh, Make sure that the calculator is in radian mode so that you can evaluate the tangent of 0.31 in radians, and then you have to multiply that by 165. So when we do that, we get 52.85 feet. And this means OA is the distance of the anchor 1 from the base of the antenna. So we have answered the first question, which is 52.85 feet. So this is 52.85 feet. We will now answer part B. This is similar to part A. So now we have to consider another right triangle OBC. So let's consider the right triangle OBC. Here as well, I'm going to apply the trigonometric ratio, that is tangent of alpha. So tangent of alpha equal to opposite side, which is OB, over adjacent side, which is OC. So I'm going to write down tangent of alpha, it is beta. Tangent of beta equals OB over OC. We are given the value of beta, which is 0.39 radians. So let me substitute for beta. This is tangent of 0.39 equals OB. We have to find OB over OC is the height of the antenna, which is 165 feet. So I write down 165 for OC. Now we can solve for OB. If we multiply 165 on both sides, we get 165 times of tangent of 0.39. So again, we plug this into the calculator. The degree has to be in radian mode, and when we do that, we get OB equals 67.82 feet. So which means we have answered the part B. So we can write down here 67.82 feet. And to answer part B, which is basically the distance between anchor 1 and anchor 2. So this is we just have to add these two distances, that is OE plus OB, which means we have to answer 52. We have to add 52.85 as plus 67.82. So when we add them together, we get 120.67 feet. This is the distance between anchor 1 and anchor 2. So we have answered all the three parts of this question.